for 8.3, and we're going to learn one last thing that has to do with revolving a area region about an axis. We're actually not going to revolve about an axis here. We're going to revolve about a line that's parallel to either the x-axis or the y-axis. So we're just going to go straight in with an example. So what we're going to do is we're going to revolve this region about the line x equals 4. So the first thing we're going to recognize is which line is this parallel to? Is it parallel to the y-axis or the x-axis? So I'm going to say, since, I'm just writing this down so you have this note. You don't have to write this every time. But since x equals 4 is parallel to the y-axis, we will partition the y-axis. Okay, the other thing we have to decide is which method. Are we doing the washer or the disk method? So this is where whatever I am revolving around, if the whole region is butted up against it, we're going to use the disk method. So this is our region. The whole region that we care about is touching that line that we're revolving around, and so we're going to use the disk method, okay? All right, so the other thing that's going to be a little bit different is because we're not doing the x or y-axis, the x or y-axis was either x equals 0 or y equals 0. Basically, it was still the washer method, but we were subtracting 0, and so it didn't apply to anything. Now, we need to look at this radius, okay, right? So again, imagine our cylinders, right? There's my little cylinder. I'm cutting infinitely many of these. Okay, so I'm doing, and my height of them is dy, and the base is pi r squared. Now, my radius, right, changes depending where I'm at. So my radius here is, so let's say I picked a point. Let's just pick a point, for example. So my radius, if it was right here at 1, my radius would be 3, right? Because I would do 4 minus 1. So that's exactly what we're going to do. We're going to do 4 minus this function, which is y squared. Okay? Because here, my radius is going to be shorter, and it's going to be 4 minus whatever that value is. Okay? And so now what I'm going to do is use my volume formula we were using before. So pi, we're doing this around the y-axis, so I need y values. So we're doing from 0 to 2. And then my radius is this guy, 4 minus y squared squared. Okay, I'm going to go ahead and span that. Let's see, we get 16 minus 8y squared plus y squared. Sorry, that shouldn't be y squared. Plus, oh yeah, it is. This should be y to the 4th then, sorry. Y to the 4th. All right, and then with respect to y. You can go ahead and enter this in your calculator or find the antiderivative. I just did this in my calculator, you guys, so, and then I turned it to I did this in my calculator, then applied pi, so I got 256 pi over 615, excuse me, and again, this is always a cubic unit when it is volume, okay? All right, let's try another one. This one is a washer. And again, I'll explain how I know is it washer or disk. So again, here's the description of the region here, but here's that already graphed and pictured. So we're revolving it around this line. So this is the x-axis up here, and we're revolving it around this line, y equals -5. So the region, that whole region, is not butted up against our line that we're revolving around, so we're going to use the washer method. Okay, so the other thing I need to know is, are we doing it with respect to x or with respect to y? So when we are deciding this, we look at our line we're revolving around. Is it parallel to the x-axis or the y? This one is parallel to the x-axis, so we are going to partition the x-axis, which means we're going to do everything with respect to x. Okay, so now because we're using washer, we need the outer radius and the inner. Okay, so outer radius. Okay, so we're doing this with respect to x. So if I look, here's my line that I'm revolving around. So this function would be furthest away, so it's going to be my outer. Now, my radius here is this line, but how far away is it from this line I'm revolving around? Well, to find that distance, we use subtraction, right? What's the difference? We did 4 minus on the other one. We always want distance to be positive, so I'm going to take the upper minus the lower in this case. So I'm going to do 2x, but then we're subtracting -5. That's giving me the distance from here to here. So this is 2x minus -5. That is that radius, that outer radius. Similarly, the inner radius is the other function, which is this curve right here, x squared, and again, minus -5, because we need that full radius, and that distance away gives us the radius of that, those discs, okay? All right, and then washer gives me the outer squared minus the inner squared. So if we set that up using our volume formula, we're doing this with respect to x, so I go from 0 to that x value is 2. Outer radius is 2x plus 5, if I simplify that, squared, minus the inner radius squared, so x squared plus 5 squared. And then we're doing it with respect to x, so dx is the thickness of all our washers. All right, doing some simplifying, I'm going to go ahead and expand these. So let's see, when I expand that one, I get 4x squared plus 20x plus 25 minus x to the 4th plus 10x squared plus 25. Okay, combining some like terms, I can distribute that negative all the way through and then combine like terms. And we get negative x to the 4th. Sorry, that is not correct. Yeah, negative x to the 4th. Sorry, I was looking at this guy. Combine my x to the 3rds, I get none of those. Combine x squareds, we got -6. 25 and -25 cancel, so then my x's are just plus 20x. All right, and then again, I just entered that in my calculator, you guys, and then attach this pi multiplied by afterwards, and we get 88 pi over 5 cubic units. All right, one more. Okay, find the volume V of the solid of revolution generated by revolving the region bounded by, sorry, apparently I repeated that, bounded by, there we go, the region bounded by the graphs, a little bit of repetition there, of these. So we've got 2x and x squared. It's actually the same region I think we were just doing. Yep, 2x and x squared. But this time we're revolving it around x equals 2. So again, a couple things we got to look at. So here's the line we're revolving around. The region I care about is not fully butted up against that line, so we have to use the washer method, not the disk. And then we need to know, are we doing it with respect to x or y? So because they want the line x equals 2 is parallel to the y-axis, so we're going to partition the y-axis. Okay, so we need our outer and our inner radius. Okay, our outer radius. All right, so of these two functions, which one is further away from our line? Well, it's this one, okay? So that is y over 2. Now, I need, what is the distance between these? So if I were to do this one, you guys, again, I always want distance to be positive, so I'm going to do 2 minus this. So we're going to write that as 2 minus y over 2. Our inner radius, we have 2 minus the other function, because now I'm looking at this radius here. So that function is square root of y. Okay, and then our volume is our integral pi times the integral. We're doing this with respect to y, so my y coordinates are 0 and 4 for my limits of integration. Outer radius, 2 minus y over 2 squared, minus the inner radius, 2 minus square root of y squared, and then all in terms of y, so we got dy there. Okay, I'm going to expand and then combine some like terms. So this one expanded, we got 4 minus 2y plus 1/4 y squared. And then here I went ahead and distributed my negative as well, you guys. So I expanded and distributed that negative. All right, so there's our, let's see, combining some like terms. Let's see, we got, let's do our y squareds. So we got 1/4 y squared. Take care of that guy. Our y's, if I combine all my y's, so I got -2, -y, -3y. Got my y's. I got this square root of y. I'm going to write it like this. And then I got -4 and 4, so that is all. And again, you can enter that in your calculator if you want, or you can do antiderivative by hand. When I entered in my calculator, here were my results. 8 pi over 3. Okay, so we can revolve or find the volume of a solid revolution using the disk method, the washer method. We're going to go around the x-axis, the y-axis, or we can also do a line that's parallel to one of those axes. That's everything. Thanks for watching.